So let's try some general solutions. Sine x is root 3 on 2. Oh, I'm smudging on my fingers. I want a general solution of this, so I'm not giving you a domain to look at. So, root 3 on 2, first of all, is our favourite old 1, 2, root 3 triangle. This is pi on 6, this is pi on 3. So, root 3 on 2, sine is opposite on hypotenuse, this is opposite here, pi on 3. So my reference angle is pi on 3. So x is, it's positive, it's pi on 3, or something else. Now what is it? In my unit circle, pi on 3 is here, sine is the y-coordinate, so the other solution is here, pi minus pi on 3. Or pi minus pi on 3, which is 5 pi on 3. No, it's not, it's 2 pi on 3. But my general solution is that, plus some number of pi's. No, sorry, some number of 2 pi's. I don't really want to write it with an or. There was a clever trick for it, do you remember? The clever trick is I'm going to go some number of pi's, and if my number of pi's is even, I'm going to add pi on 3. And if my number of pi's is odd, I'm going to subtract pi on 3. So let me write that more correctly. It's some number of pi plus negative 1 to the n times pi on 3 for some integer n. So look at that again. When n is even, I'm going to get a positive 1 here and get pi on 3 added on. When n is odd, I'm going to get negative 1 here and subtract it. So that's my general solution. Let me give you another one. Cos x is minus a half. Well, minus a half is our old friend, the 1, 2, root 3 triangle. Cos of a half, adjacent on hypotenuse, adjacent to this angle, which is pi on 3. But I've got negative a half. So which quadrant am I in? If cos is negative, I'm over here. Minus pi on 3 plus pi on 3. So I'm going to pi, I'm going to odd numbers of pi. So x then is an odd number of pi, 2n plus 1 pi, plus or minus this reference angle, pi on 3, for some integer n. Let's try another. Tan 3x is 1. Now 1 is our favourite 1, 1, root 2 triangle. Tan of 1 is pi on 4. So my reference angle is pi on 4. That means 3x is, well, it's pi on 4 plus some number of pi. Remember, tan repeats every pi. That's close. That's 3x. I want to find what x is. So x must be, divided by 3, pi on 12 plus n on 3, n pi on 3, for some integer n. Okay, let's try another. Cos 2x equals 0. Looking for a general solution. Well, cos being 0, cos 0 is going to be here or here. So it's pi on 2 or 3 pi on 2. Actually, it's going to repeat every pi. It's actually going to be just like the tan. 2x is going to be some number of pi plus pi on 2. That's 2x, repeating every pi at pi on 2. So then x must be n pi on 2 plus pi on 4. Now this isn't the standard way, I should go for n integer. Now this isn't the standard way that we would normally write this, because cos we would normally be writing as some number of 2 pi plus or minus. But because it's pi on 2, I can actually simplify it into the same kind of style as we did for tan.